So what we've discovered from the last couple of videos is that there's a real important connection between the factors of a polynomial and the x-intercepts of a polynomial. Or another way to say it is the factors of a polynomial. If you know the factors of a polynomial, then you can find the roots or the zeros of a polynomial, and those of course will give you the x-intercepts. And I also made the connection between, if you know the x-intercepts and the end behavior of a polynomial, then you can fairly easily and quickly sketch a rough graph of it. So here's a polynomial. It's a fourth degree polynomial. You can tell because the highest power in this is 4. It also has a positive leading coefficient. And remember, from that, we can determine the end behavior. So the end behavior of this, I'm going to write that as f of x just because I know that's the same thing, but okay. So we can say that the limit of f of x as x approaches infinity, which means as we go out to the right, what's happening? It's positive infinity. As we go out to the left, it also is headed to a positive infinity. So this is, I guess I should have said that end behavior. This is end behavior that we're talking about right now. Okay, so now the next thing we'd want to know is some x-intercepts. Now, of course, if it's a quadratic, we usually can find the x-intercepts pretty easy by just factoring if it's factorable. If it's not factorable, then we can use a quadratic formula. But of course, unfortunately, there isn't a fourth degree. There isn't a kind of similar tool like the quadratic formula for a fourth degree polynomial. So we have to come up with some other way to come up with the factors which would lead us to the roots, which would lead us to the x-intercepts. So again, the whole idea is we're trying to find out if something is a factor of this function or not. So one way we can do that, which you all will be thrilled about, is let's say I wanted to test to see if x plus 1 is a factor of that polynomial. Well, one way, just like back in the old days, if I wanted to know if 5 was a factor of 30, let's say, the way I could find out is say, does 5 divide into 30 evenly? And of course, we all know that 5 times 6 is equal to 30. So by doing division, we can find out that 5 is a factor of 30. So we're going to do the same thing with this. And right now I can hear the moans of the people that in the future that'll be watching this video. Because I know that long division is not necessarily high on your list of things that you really love to do. Okay, so how do you do long division with polynomials? I can go ahead and take this off now. So again, I'm trying to figure out if this is a factor of that. So if we're looking for, what would tell us that it's a factor is that we would get a remainder of 0. Remember back when we were doing division, if you did, for example, 7 into 30, you would say, oh, well, that'll go in there 3 times 7 is 21. We subtract 21 from 30 and we get 9. Whoops. Oh, well, let's try 4 then. 4 times 7 is 28. We subtract 28 from 30 and we get 2. And we're at the end of the 30, so we have a remainder of 2. That tells me that 7 is not a factor of 30. So we're going to look for something similar here and do that same process. So over here, we asked what times 7 equals 30, and the closest we could get was 4 times 7 equals 28. So we're going to do the same thing here, well, similar. So because there's 2 terms here, we're going to go to the second term. So we're going to put our number over the second term, or just like we put the 4 over 30 there, because 7 wouldn't go into 3, we had to go over to 30. Here, because there's 2 terms, we're going to go over to the second term. but we're going to ask ourselves, what times x equals this first term here, x to the fourth? And of course, the answer is x cubed. X cubed times x does equal x to the fourth. So then we're going to do just like the 28 we came up with here. We're going to we got that by multiplying 4 times 7. So now we're going to multiply x cubed times that. So x cubed times x would give me x to the fourth, and x cubed times 1 would give me positive x cubed. And just like over here we subtracted 28 from 30, we're going to do the same thing here. We're going to subtract that from that. So x to the fourth minus x to the fourth is, of course, 0. That we set it up that way. And then negative 2x cubed minus 1x cubed would be negative 3x cubed. Because notice we're subtracting this, right? And so then, because we haven't got at the end of our number, we're going to bring this next one down. So we'll have a negative 7x squared there. And we're going to start the process over again. So we ask ourselves, what times x is equal to negative 3x cubed? And the answer is negative 3x squared. So then we'll multiply that by that. Negative 3x squared times x is negative 3x cubed. And negative 3x squared times 1 is negative 3x squared. Once again, we're subtracting this. Negative 3x cubed minus a negative 3x cubed is 0. Negative 7x squared minus negative 3x squared is really like negative 7x squared plus 3x squared. So we end up with a negative 4x squared. Bring down our 8x, so that'd be plus 8x there. And we'd start the process all over again. What times x gives me negative 4x squared? And that would be negative 4x. Multiply that through. Negative 4x times x is negative 4x squared. Negative 4x times 1 is negative 4x. And we're going to subtract that. Negative 4x squared minus a negative 4x squared is 0. 8x minus a negative 4x would really be 8x plus 4x, which would give me 12x. And finally, we bring down the 12, and now this is really where we're going to get to. Is there going to be a 0? The anticipation is building. We're so excited to find out. What times x equals 12x? That would be plus 12 here, because 12 times x is 12x. And then we multiply it again. 12 times x is 12x. And 12 times 1 is 12. Oh, look at this. Look at this. We subtract them. 12x minus 12x is 0. And 12 minus 12 is 0. So we get a remainder of 0. Yay, that tells me that x plus 1 is a factor of 3x, of x to the fourth minus 2x cubed minus 7x squared plus 8x plus 12. In fact, even more so, it tells me, just like if we do 5 divided into 30, and we put a 6 up here, 6 times 5 is 30, and we get a remainder of 0, that means that 5 times 6 is equal to 30. So we can write that in factored form, right? So we can have a similar conclusion here, that x plus 1 times x cubed minus 3x squared minus 4x plus 12. Things ran into the top of each other. Minus, what was it, 3x squared minus 4x plus 12. So if we multiply those two things together, we get x to the fourth minus 2x cubed minus 7x squared plus 8x plus 12. So we've begun to factor this fourth degree polynomial. So we took out one factor, now it's down to x cubed. So that's nice, although if we go back and look how we did that, that's a little bit daunting to think that I'm going to have to do that every time I'm looking for a factor, because we know there's obviously a potential for 3 more factors here. Why do we know that? Because it's the third degree, so notice when I took one factor out, it dropped from a fourth degree down to a third degree, didn't it? Okay, so before we get too nervous and upset and distraught, I'm going to show you a little magic. Okay, so I'm going to take the coefficients of this fourth degree polynomial. And I'm going to write them right here. So that'd be 1, -2, -7, 8, and 12. Okay? And then I'm going to take the, make sure you follow this, I'm going to take the root that's associated with this factor. So if this is a factor, we know the root that's associated with that is the number that makes this equal to 0. So we all understand that that would be -1, right? Because if I plug -1 in for x, that would make this factor equal to 0. So I'm going to take the root that's associated with that factor, and I'm going to put it in a little box here. So that'd be -1. Okay? So where do these numbers come from? You can see the 1 comes from that coefficient of x to the 4th, -2 comes from the coefficient of x cubed, -7 comes from the coefficient of x squared, 8 comes from this term, and 12 comes from the constant term. So now what we're going to do is a series of addition and multiplication. Okay? So first I will add 1 to whatever's below it, which is nothing. So 1 plus nothing is 1. So that's the first step, is adding. Then I'm going to multiply. -1 times 1 is -1. So that's all I'm going to do over and over again. So I just added and then multiplied. Always adding the number in this row by whatever's below it, and then always multiplying whatever number ends up down here by the number in the box. So now notice -2 plus -1, of course, is -3. And then I'm going to multiply it by the number in the box. -1 times -3 is +3. Then I'm going to add again. -7 plus 3 is -4. Then I'm going to multiply again. -1 times -4 is +4. Then I'm going to add again. That gives me 12. Multiply. -1 times 12 is -12. And I add again and I get 0. Now at this point, some of you are probably freaking out a little bit because you notice that and others are going, why would you freak out? Because you didn't notice it. But notice that these numbers here are matching up with the coefficients of the answer to the division problem we just did. So that 1 goes with the x cubed, the -3 goes with x squared, -4 goes with x, and the 12 goes with the constant. And notice the 0 matches up with my remainder. So this is a magical little tool. It's math magical, if you will, called synthetic division. Synthetic division. It's called synthetic division. You probably recognize the word synthetic. It's actually kind of another word for fake. So we're really just kind of faking division here. So by this process, it actually simulates what we just did up here, but in a quicker, more efficient process. So what we've done really here is we've faked, if you will, dividing x plus 1 into x to the 4th minus 2x cubed minus 7x squared plus 8x plus 12, and got an answer of these numbers here. What do these numbers mean? Well, these are coefficients of a polynomial. How do I know that it connects back to x cubed? Because I divided x to the 4th degree polynomial by one factor, so that means that I should be left with a 3rd degree polynomial. So again, these numbers represent that polynomial. So this makes it a little bit easier to do division over and over again. So now we know this. So now what I'm going to do is I'm going to take that 1, -3, -4, 12, remembering that it represents that polynomial up there, and I'm going to check for another factor, like say 2. Now remember, if I put a 2 in there, that means I'm really checking to whether x minus 2 is a factor or not, right? Because 2 is the 0 or the root that goes with that factor. Okay, so I'm going to do synthetic division again. 1 plus nothing is 1. 2 times 1 is 2. 2 plus -3 is -1. 2 times -1 is -2. -2 plus -4 is -6. And 2 times -6 is -12. And yahoo! I get a 0. So what does that tell me? That tells me that I have a remainder of 0, which means x minus 2 is a factor. More specifically, that x minus 2 times what's left over here, or the answer to the division problem. And notice this was a cubic, right? Because we can see it right there. So if I've factored out one more factor, now I'm down to a quadratic. So this would be 1x squared minus x minus 6. So again, what I'm saying is that x minus 2 times this is equal to 1x cubed minus 3x squared minus 4x plus 12. But keep in mind, this came from that up there. So really what I'm saying, the ultimate thing I'm saying is that x plus 1, because of this factor up here, times x minus 2, because of that, times x squared minus x minus 6 is equal to my original polynomial, which was x to the 4th minus 2x cubed minus 7x squared plus 8x plus 12. So we're getting closer and closer to this thing being factored. So now, notice that what's left here is a quadratic, which we have some experience factoring. So at this point, I may be able to just stop this whole synthetic division process and just go ahead and factor. So I'm going to try that. This would be x plus 1 still. This would be x minus 2 still. And can I factor this into, there'd be x and x. And in order to get 6, I have to do 1 times 6 or 2 times 3. 2 times 3 has a difference of 1. So I'm going to go with 2 and 3. And if I make the 3 negative and the 2 positive, notice that negative 3x plus positive 2x would give me negative 1x. So now, because this is equal to that, that means this is also equal to that. So I have just taken this 4th degree polynomial and have written it in factored form, using a little bit of synthetic division and also just good old-fashioned factoring of trinomials. Very exciting. But what else have I done? I've also discovered the x-intercepts of this polynomial. So we know the x-intercepts because roots give me x-intercepts and roots come from factors. The x-intercepts would be negative 1, 2, negative 2, and 3. Negative 1 comes from this factor, 2 comes from this factor, negative 2 comes from this factor, and 3 comes from that factor. And so if I wanted to sketch this thing, again, I'm not worried about hitting every single point, but I'm just going to roughly sketch it. I know it has to go through negative 1 and negative 2 and positive 2 and 3. I also know that it has a positive leading coefficient and it's 4th degree, which means the end behavior, I think we discussed that up here. Where's the end behavior? End behavior is positive on the right and the left, positive infinity on the right and left. So that means that I'm going to have something that looks kind of like this. Do I know it looks exactly like that? No, I don't know how high or low the bumps go, but I do know that this point is right, this point is right, this point is right, this point is right, and the end behavior is correct. As far as the bumps, they may be skinnier, they may be taller, I don't know exactly. But this is a quick, rough sketch of that polynomial based on the x-intercepts that I know are correct and the end behavior that I know is correct.